inches to feet, grams to moles, technically molecules to moles. But so there are two different types of conversions. First off, we have the exact conversions. Now, these are conversions that have infinite significant figures. And what that means is that one value is defined by an exact number of the other value. So, for example, we know that 1 foot is equal to 12 inches. 1 foot is exactly 12 inches. There's no approximation in that. Now, similarly, we also have that 1 inch is equal to 2.54 centimeters. That is also an exact conversion. So now I'm just going to write out the rest of them for the moment. So we also have that 1 pound is equal to 16 ounces. By the way, I write all of my C's with the cross going through it, just for future reference. We have that 1 quart is equal to 16 fluid ounces. We know that 1 yard is equal to 3 feet. We know that 1 angstrom is equal to 10 to the negative 8th centimeters. We know that 1 gallon is equal to 4 quarts. And we know that 1 quart is equal to 4 cups. Now, for the last three, we know that 1 mile is equal to 5,280 feet. We know that 1 atmosphere we know that 1 atmosphere, which is the atmospheric pressure at sea level. So it's the air pressure kind of walking around outside at the beach. And that is equal to 760 torr. And finally, we have 1 gallon is equal to 16 pints. So all of these are exact conversions, and the useful thing about any conversion is that you can divide one by the other in order to convert between units. So, for example, say we want to convert 24 inches into some amount of feet, right? So we know that 1 foot is 12 inches. So we can take our 24 inches, and because we want to get feet, we divide both sides by inches. So this cancels out to 1. So we'll say that 1 foot over 12 inches is equal to, now the inches cancel. 24 divided by 12 is 2, and the unit left is feet. So we find that 24 inches gives us 2 feet. Now, there aren't only exact conversions, because sadly, not every conversion is exactly known. But what we do have, in addition to those, are approximate conversions. Now, these are conversions that do have some defined number of significant figures, and that will depending on how many are in the equation that you're given. let's take the fact that 1 gallon is approximately 3.785 liters. So in this case, we have 1, 2, 3, 4 sig figs in this conversion. Now some other ones that we have that 1 atmosphere is equal to, we have that 1 AMU, an atomic mass unit, is equal to 1.66 times 10 to the negative 24 grams. AMU, atomic mass unit, also known, maybe more recognizable as a kind of a gram per mole. There's a slight difference between the two of them, but so we also know that 1 calorie is equal to 4.183 joules. So calorie, many of you guys, you probably have heard of that before, and you get it with food. So the food calorie is actually known as, some people call it a big calorie and write it with a capital C, or they call it a kilocalorie. But a food calorie is worth 1,000 small calories, and each small calorie is 4.183 joules. And this refers to the amount of energy it takes to eat 1 gram of water, 1 degree Celsius. So a couple other conversions that we have that 1 atmosphere is equal to 1.013 kilopascals, which is also equal to 1.013 times 10 to the 6th dynes per centimeter squared. And we also have that is approximately equal to 14.7 psi, pounds per square inch, which is another form of pressure. Just for reference, pressure is equal to force applied over an area. So as many of you guys know, pounds is actually a measurement of force, not mass. And square inches, so area is some sort of length squared. So pounds per square inch is pressure. And finally, we have an approximate that 1 pound is approximately equal to 453.6 grams. Another even less accurate approximation, but still a very useful one, is that 1 kilogram is approximately equal to 2.25 pounds. That's specifically under Earth's gravity, though. That will change depending on where you are. So finally, we'll go over some constants. So, our constants. We have R, which is the ideal gas constant, which is equal to 8.314 joules per mole Kelvin. And we also have that it is equal to 0.08206 atmosphere liters per mole Kelvin. Now that actually is a little fun fact that pressure times volume equals energy. Go back up here. essentially have that d times some length times an area times a pressure equals energy. But we'll go over this more later. But in addition to this, we have that c, the speed of light, which is equal to 2.998 times 10 to the 8th meters per second. We also have n naught, which is Avogadro's number, which is equal to 6.023 times 10 to the 23rd. And that is molecules per mole. So in 1 mole, let's say oxygen O2, you have 6.023 times 10 to the 23rd O2 molecules per mole. Now we have 0 Kelvin, which is absolute zero temperature, which is equal to negative 273.16 Celsius. And finally, we have Faraday's constant, which is 96,500 coulombs per mole. Coulombs is a unit of charge, so this is charge per mole. But I hope that this is helpful and that you guys can use this to study or potentially relax to it. But I wish you best of luck, whatever you have coming. I'll see you later.